Welcome back. So today's lecture will be discussing the comparer, generic comparer class or comparer T class for sorting the C# user types or user defined, classes like employee class that we have seen frequently in our last few lectures. So the learning outcome is to learn how the sorting of several objects of the same type or the same type of object instances, separate instance of the same type is done using iComparability by name say default, and extend this idea to use comparer T for more flexibility by being able to sort the objects by salary. So the lesson plan as usual is within the Visual Studio. After flipping to Visual Studio, we will actually see that the employee class will be changed to implement iComparable employee. Okay. And later on, we'll extend the default sorting by name. Initially, it will be sorting by name that we'll implement, and we'll then extend that default sorting by name to have sorting by salary as well through another class that implements the comparer of employee class, which is in focus, which is the topic of today's discussion, comparer T class. So now run the app to see the output. So comparer for comparing C# types. Comparison allows us to compare variables of the same type. This can be further used for sorting the elements in a collection. If a C# class wants to tell the outside world about its comparison capability, it needs to implement iComparable interface. Let's see an example. So we have got a string array, air animals, which is initialized as new string with these items. Tiger, lion, elephant, rhino. These are all strings actually. Animals represented as strings, you can say. And then we have got, sort method of the array class. So array.sort, and we can pass this array of string array, air animals. Now on the next line, we are writing string.join, and within a \n is new line character. Every of these elements of the string array will be written in the new line. So this is what it will do. When the above code is run, it will show this, elephant, lion, rhino, tiger. Now elephant, lion, rhino, tiger is sorting by alphabetic, or alphabetically it is sorted. So E comes first in the alphabet, then followed by L, and then R, and then T. Okay, so this is known as alphabetical sorting. Right, now using iComparable in employee class. So we can see array of strings has been able to sort itself as it knows that how to compare itself. Now we haven't discussed it so far. So how will we say that it knows how to compare itself? We'll see that. This innate capability to compare and sort a string is given by the implementation of iComparable interface for the string class. So if we now for a second flip over to the Visual Studio, so I have flipped over to Visual Studio, and here I will write this code that we have just shown you on the slideshow. So that code will be I have copied it on a clipboard and just pasted. Now just get rid of these unnecessary comment statement, uncomment this. Right, and then this static void main is already there. I need to get rid of this and just the bare minimum thing. Right, now this one, let's run this code. So if we run this code, let's indent it a little bit. So Control F5 to run. So you have got this one. Now what happens is, let's put the breakpoint over here, array.sort, and run the application in the debug mode. Now what happens here is that when it reaches this breakpoint, Then air animals, it sorts, the sort method. Now here you can see that, tiger, lion, elephant, rhino, it is still there. And then if you go to the next line, if you put the break point to the next line, if you just carry on, then what will happen is that, this will have sorted itself with elephant, lion, rhino, tiger. So it is already sorted. And then what happens? Let's see the sort. Go to the definition. So this sort method, actually, it takes an array of, generic class T array. And then now if you browse over and then right click to go to the definition of the string class, you can see that it implements so many interfaces, IEnumerable char, IEnumerable, IClonable, IComparable, and IComparable string. And that was what I was telling last on this slideshow, that the innate capability to compare and sort a string is given by the implementation of IComparable interface for the string class. And from the result, we can see that it is this capability of string class to sort itself alphabetically. Now that I have employee class below and I want to compare all the employees by their name. Okay, so in this slide, so this is the public class employee and I want to sort it by name. Okay, so let's make an array of employee. Right, so array.sort array employee. So I am just calling the name property, Abhishek, Greg, and Thomas, and then trying to sort it through the calling the sort method of the array type and passing the array employee. Now what happens is there is an unhandled exception, So it says that failed to compare two elements in the array, at least one element must implement IComparable. So that is the keystone of today's lecture. So as we run this code, we'll get the exception failed to compare the two elements in the array. At least one object must implement IComparable as shown in the figure. Okay, so we can pretty much prove this, for a second. Okay, first let us prove what we have told earlier, that the array of animals, string array of string. Let's see how it works, whether it works or fails. So it works, elephant, lion, rhino, and tiger. Now let's change the code. I have put this, let me remove this, and I have placed the code on my clipboard to save time, and then indented a little. And then let's run this code, try to run this code and see what happens. And you can see that, it comes up with the unhandled exception exactly as I showed, at least one object must implement IComparable, as I showed here in this slide. Okay, right. So let's kill this and go for this. So here, if you go to the next slide, to provide the default implementation of the comparison for the class so that it can be sorted in a collection, we need to implement the IComparable interface. Now I will show you the C# code soon in the Visual Studio, but first of all, let's see it on the slideshow. So now you see, as I have told you in the learning outcome, now the employee must implement IComparable of employee type interface. And how it will do that, there is just one method that it needs to implement from IComparable employee, that is compared to, and in the compared to method, the employee object is passed. Okay, an instance of the employee object is passed and it returns a integer, right? So let's go back to the code. Now I have already implemented the iComparable of employee on this. It is employee class is now modified to implement this iComparable interface, and the method that it needs to implement, as I showed on the slide show, it is pretty much the same code. It is implementing compared to with getting the employee instance other, and if this is the current instance of employee, this dot name dot compared to this other dot name not equals 0, then return this dot name dot compared to other dot name, and otherwise return 0. Okay, so this compared to, let's see what this compared to does. Go to definition. So this compared to, that is returning an integer, and on the summary it says that it compares this instance with the specified system.string object and indicates whether this instance precedes, follows, or appears in the same position. So if you look at this returns, if you just expand this note, value condition less than 0, this instance precedes string B. Okay, 0, this instance has the same position in the sort order as string B, and greater than 0, this instance follows string B, or string B is null. So here we are checking for 0. That means we are checking for whether this instance has the same position in the sort order as string B, but that is not what sorting is. So if it is other than 0, not equal to 0, then return this, what is either the positive value of integer. Okay, the return integer is positive or negative, not 0, else return 0, right? And then coming back to the comparer collection class, so I have already put this code, and then this was just for the demo purpose, just to show its compatibility with what is being told on the slideshow, but I will just remove it. This is of not much use. So instead I have copied some code on my clipboard to be pasted over here just to save time, because it's a lot of, I have created 5 instances of the employee class, and then an array of employee is created, employee array, which where I have put all these employee object, employee 1, employee 2, 3, 4 and 5 as the array of employee. Now I want to do the let's compare first by default sort by name. Okay, so for sorting by name, this is already in place, this is already implemented. When employee class has implemented iComparable employee, this part is already explained that how does it compare the name of this instance with the other instance that is put to this as an argument to the compare to method, right? This we have already discussed. Now let's run this application in the debug mode, and before that I need to write another, I need to call the sort method on the array object. So array dot sort, and pass it. See, it is expecting one of the implementations, one of the overloads is array. So this is the employee array. So this is our employee. I will pass this object. Okay, so our employee, however you pronounce, and then it will be comparing it by name. Okay, let's just in the debug mode, just click run the application. Right, nothing will show because nothing is written. Now what I want you to check is the array employee. So how will you check? On the mouse over, oh sorry, this is already finished running again. So on mouse over, you can just click and you can see the 5 objects of this array. So first object is department ID name. Name is of special significance. It starts with Jack. And the second object, the name is Jill. So it is in ascending order, sorting. And then Judy. Jack is J-A. J is common, then A. Then Jill, then Judy. And then alphabetically now it is sorted, Noel. And then final R is Ruby. Okay. So it's the default implementation of name that's proven, that is shown. Now how to implement. Now tomorrow, say for example, tomorrow another requirement comes to you from your boss that you need to do the sorting on the employee object class by salary as well. So how do you do that? So if you go back to the slideshow, when a requirement comes where we need to get my employee collection to be sorted by salary, in this case, we have to answer this question. Should we make a change in the employee class to do this new comparison? It's not a great idea to keep changing the employee class for each and every new comparison, and especially that we have already a default comparison for the employee class by name. So for this new sorting requirement, we should have a class, which we have to make a new class which implements the comparer T class, where T is the employee. Generic comparer. Okay, so this new code snippet will be like this, which I will just implement here. Public class salary comparer. It now implements, or it derives from comparer class. This comparer class I will show in a second. It is an abstract class, and it has to override compare method, which takes in 2 parameters, employee X to employee objects, and then returns x.salary.compare to y.salary. Okay, so going back to the code, let's make a new class here and delete this breakpoint. So public class. Now it's a salary comparer class. Let's name it salary comparer. And it implements the comparer of type employee, right? And all it does is, so let's see what it should implement. Let's go to the definition. Now this is an abstract class, and it implements 2 interfaces, iComparer and the generic iComparer. Both are iComparer, and it has got a public abstract method, which returns integer, and it accepts 2 generic parameters, x, tx and ty. Okay, now I need to actually override this in the implementing class, which is this salary comparer class. So how will I do that? So I will write public override. So if it was an abstract, it has to be overridden, public override int compare so automatically when I click the enter after writing this part, it automatically created the shell with the arguments passed in, and then not implemented exception, where I'll just write the code, just a single line. It returns. Now I've got x and y. X dot salary. You are comparing on salary dot compared to. You can see that you can compare on practically anything if it is of that type. If it returns that type, of course. Now the ID and the salary returns an integer, so you can possibly compare by ID or salary, not the department, which is returning a string. So that's it. And then to finally have the comparison by salary, I'll just delete this or just modify this to have another argument. So it has got several overloads, array keys, array items. So that is one of them. But this will have to be a new salary comparer object. Salary comparer, pair of circular braces. That's it. And then I just put the debug point and a breakpoint over here. Run this application. And when it hits the breakpoint, I will look into this array employee. Now this should have sorted it by salary. See, its salary, first salary is 3,500, and then 4,500, then 5,000, then 5,500, and then 7,800. So it's all sorted with the salary here. So basically that's it. And before leaving, we'll recap. So from a quick recap of the lecture, we see that we have learned how the sorting of several objects of the employee type is done using iComparable employee, and how to extend the default sorting by name to now have sorting by salary as well through another class named salary comparer that implements comparer employee. That's it.